So we're going to be talking about biofuels, guys. Fields of flax, sunflowers, and corn. Do they make you think of cars? These plants all play a part in making liquid fuels called biofuels that can power cars, tractors, buses, and more. Biofuels are made from biomass, which is matter from living things, especially plants. One advantage of using more biofuel is that we use less fossil fuel, such as gasoline. Another benefit is that only are plant renewable, but the carbon dioxide they release when they burn is balanced by the CO2 they take in when they grow. Some negatives are that gases are given off during the production and transports of biofuels. The processes of cleaning land in order to turn it into cropland also generates greenhouse gases. Scientists are hoping that one balances the total output of CO2 is less than this. But this is still being debated and always and will forever be debated. Look at this one. It's a sunflower. More than just a pretty face. Though it can be a bit costly, sunflower oil is being looked as a resource for both ethanol and biodiesel fuel. Some farmers make biodiesel fuel from oil extracted from the sunflower that they grow. They mix the oil with the ley and alcohol to create biodiesel to fuel their trucks and tractors. It's pretty interesting. So basically, plants can be used as energy sources to give or run and be like a gasoline or fuel. So the oil of it runs vehicles, buses and trucks and tractors and all that, which is pretty awesome. And regular cars as well. So it's pretty awesome. It's not just a food source. And this corn alone also can be transferred or, made to powder, like a powder substance. Making tortillas, corn tortillas. And sunflower seeds can be dried up. The seeds of the flower can be dried up in the sun and you eat it like that. Or in a salad. Or popcorn. Do you understand? So think about all the opportunities that you have in your fridge to look at what kind of food you have in there and what types of things does that one piece of food help in your world. What other, ideas can help. Like, for instance, berries. Berries are not just growing and from vines and that's it. They use berries to make wine. There's also other ingredients for seasoning, flavors and stuff that they use berries, and also can be a form of jelly. You understand? So one type of food can be used in so many different ways. Okay, that's pretty much what they're saying, okay? Now we're here looking at super cool frogs. Like all amphibians, frogs are ectotherms, meaning their body temperature depends upon their environment's temperature. So basically what that means is that a frog is going to stay comfortable and stay living in their natural habitat compared with their habitat and the temperatures of their habitat. It could be also what kind of habitat do they live in? Is it a dry habitat where there is no water, or is it full of water? Or is it half water and half not water? There's also not just frogs, but toads, that are within the family of frogs. So basically meaning that if a frog is grown in the water, that's it. It's a water amphibian. It lives in the water, it survives with water, and it needs moisture. Unlike a different frog where it grows in the habitat of where it's mostly dry. Doesn't live on, in the water. It lives on the ground or underneath the ground, digging, in the dirt, for instance. Okay, here it says, amphibians have many ways of dealing with cold winters. Some species of toads dig deep holes, like I said. Newts hibernate underground in existing holes. Okay, so holes that are already made from either other animals or other toads or newts. Some aquatic species live in the water below the ice. Spring keepers, frogs from East North America that are about an inch, 2.54 centimeters long, can winter in less protected areas, under logs or up in trees. This one's called the wood frog on ice. Oh, okay. It says wood frog on ice. Okay. The temperatures at which each of these frogs begins to freeze also plays an important role in helping them survive. A substance is supercooled if it remains liquid before the freezing point. The cryoprotectant in the frog's cells lower the temperature at which the frog will freeze. For each of these frogs, their bodies supercool only a few degrees before ice begins to form. For example, wood frogs supercool only to between 25 degrees Fahrenheit and 26 Fahrenheit. Before they start freezing, they reduce the possibility of ice growing too quickly, demanding the organism. Instead, the process of ice forming is carefully controlled. Ice growth tropically starts in the frog's hind limbs and ends in the brain. Interesting. Here we are looking at geysers. I believe it's different landscapes. What do you get when Mother Earth, well, we don't believe in mothers. What do you get when the Earth lets out a steaming burst? A geyser. A geyser is a hot spring that erupts These eruptions send steam and boiling hot water into the air. There are only about 1,000 active geysers on Earth. I said geysers, sorry. Geysers on Earth. They are so rare because they form only under very specific conditions. Okay. For geysers to form, they must be a lot of water filling a system of watertight underground cracks. These pipe-like cracks must be able to withstand great pressure. Okay, pressure is like a form of force. There's like it doesn't allow it to go anywhere. Almost like a suffocation situation. You know, if you're suffocating air like that. Most importantly, this water must be located near a very hot place, such as underground pocket of melted rock or magma that feeds a volcano. So like in a mountain, large mountain. Such heat from the deep underground is called geothermal energy. In nature, geothermal energy powers geysers, many kinds of rock changes, and volcanoes. People use geothermal energy to geothermal power plants are like human-made geysers. The hot steam that comes up can be used to power turbines that generate electricity. Okay, so I really didn't know that. It's pretty interesting. So this like form of lava is connected with power plants that are connected to creating power turbines that are connected to electricity, generating electricity. That means creating electricity, which is pretty awesome. Pretty awesome. Okay. So now we have here, we don't want to know about this. Oh, fungi. Fungus. Fungi are such unique organisms that form their own scientific kingdom. Who remembers range from unicellular organism? Okay, so basically fungi is like algae and fungus. You know, it's like a bacteria kind of, but there's good and there's bad bacteria. And there's good bacteria. So like mushrooms, we eat mushrooms. We're actually eating fungus, mold. But that's a form of good bacteria. Sometimes our body asks for, a specific bacteria to kill another bacteria that's in our body. Okay, so fungi secreted. I can't read that now. How about let's read this one. This is called fly agaric beware. Fly agaric, which is right here that you see, agaric is definitely not for eating. Okay, so if you see this, don't eat it. This fungi has been used to kill flies by attracting them to milk that has small pieces of poisonous fungi soaking in it. Okay, so the individual thread-like cell of fly agaric's mycelium called hyphae taped into tree roots to obtain nutrition. Okay, so these things are usually found near tree roots because that's how they obtain, their nutritional value. They're also poisonous, so you don't eat it when you see it. If you see another specific mushroom, then you just have to get more information about it. So here we're looking about thunderstorms. Thunderstorms are nature's display of fireworks. Okay. They produce lightning and thunder and are usually accompanied by rain or hail and wind. Beautiful and powerful. Thunderstorms can also be deadly. Clouds form as moisture air rises from the earth, warm surface. As the air cools down, the cloud will fill with millions of particles of ice. Those particles collide with each other as the wind moves them up and down inside the cloud. These collisions are particles and what builds up electric charges. As negative charges, particles are attracted to areas of positive charges, they produce a large spark, which is lightning. Okay, so basically with the negative charge, particles are attracted to the area of positive. Okay? Negative and positive charges are together and they are attracted together. Attract means like when they want to come together. It's like a magnet. They're like connected together. That's when they form that specific attraction and they create lightning and spark. Some thunderclouds build a negative electrical charge at the bottom of the cloud. This causes the Earth's surface to become positively charged through what's called induction. Negatively charged particles on Earth's surface are repelled by the like charges at the bottom of the cloud. So they move away. That's interesting. And look at that picture. Wow. These are real, actual photos. Okay, so now we can read here. Now, wow. In Ohio, there's caverns as well. So let's read about these ones.
TV died. The TV
Okay.
ran out of battery.
Look at the caves, Logan. You know, I went to go see some caves in Ohio. They have nice ones. They're called the Ohio Caverns. We can look them up. I know, Titi Rachel gave you this. We just gotta get a Wii. It's cool. It's a game. Oh. Okay, now, guys, let's read. Look at all these animals. This is called the what? Good old house kitty.